All right. Let's finish up a couple of slides remaining for the introduction, and then we'll go into nutrition labeling, and that's Lizzie. Okay. Let's just couple of recap before going into the last few slides. Can you give an example of some tests you would want to do in case it's product development? Give an example and a test or a couple of tests, then competition, then change in process, and food forensics. Let's start with product development. What would you be looking into? Give an example of a product development and what would you be testing? Well, happy Monday to you all. I know Monday is a struggle. We all are tired after the weekend, whatever we're doing. Okay. All right. If you're developing amyloid bakery products, you call them. Okay. So, for example, you're developing a new product, what Lizzie said, and you want to look at potential storage stability, and this is very important determinant. And active water is very important determinant, or available water. So look at water activity. That's a good one. All right. So can you give an example? If you're trying to compete with someone, what would the first thing you want to do? Go ahead, Maddie.
Go look at their ingredients for nutrition label.
Very good. So the first thing you want to do, you go get that product. And if you have a nutrition label program, try to do a reverse engineering, something that you will do as part of the lab on Wednesday. Very good. So that's one. And then you want to understand the composition and see how you can make it similar. I mean, some sensory tests and a lot of other things. So just good. If the process has been some change that caused, well, either new equipment or another unit operation, what would you want to look at? You gave an example of soy flour. Do you remember that example? So if you change the unit operation, you want to say, for example, we did say, well, the protein change. Look at the protein digestion change that was for a specific application. But let's say another type of product, you want to look again, stability of it. Did anything change that might have caused potentially, if it's a high fat acidity, for example? So anything that you change in your operation, you want to think of what component that food or ingredient could have changed, and then you would do tests related to that component. And then food forensics, there are so many different examples for food forensics. Do you remember the one we gave last time? That falls under food forensics. Somebody saw something that said it's glass. What did we mean to this? Like glass or something else? Yeah. So okay, what is that? Is that a glassy material? And it turned out to be not a glass, it was crystallized sugar. That's a funny example, but there are a lot of, actually the example about the complaint of that cereal, fried cereal, when you go and take a sample and make the package and take even a sample of oil, that goes all under food forensic too. You're having an investigation to determine what caused the problem. Okay, good. So continuing with the choice of methods, we did talk about when you want to analyze a component of food or a characteristic of food, there's so many methods that will be available to you.
And you're gonna learn a lot about different methods, but also how to choose and when to choose what method. A part of our choice of the method has to do with the objective. What is our objective? So to give you an idea, if our objective is nutrition labeling, you want to do compositional analysis to put the protein content, the total fat, the saturated fat. So you want to develop your nutrition label. So your method of choice has to be an official method of analysis. Have you heard of this term? Official method of analysis? And what does it mean to you if you have heard of it? I don't expect you to know, but in case you do, or you have an idea, would you tell me? When you hear the word official, okay, go ahead, spell it, huh?
Maybe what's accepted by the FDA or organizations.
Very good. What's accepted by an organization? Could be FDA, could be different organization. But for a method to be accepted by an organization so that it gets the title official method, it has to go through a series of validation. So a method will be developed, tested in multiple labs, an application is filed to, let's say, AOCS or AACCI. We'll talk about all of these organizations. And then it gets stamped as reliable, accurate, precise. It gives you what you're looking for, reproducible. Then it gets the stamp of an official method of analysis. But sometimes it has multiple names. So official, primary, definitive, reference, they all mean the same thing. A method has been validated, it's reliable, it is the method of choice or a reference. So the reference method is usually used to calibrate methods that are quicker, like if you have an IR instrument online to determine fat content, moisture content quickly, like NIR or MIR, mid-IR or near IR. We'll learn a lot about those later. It is a method that needs to be calibrated, and often these methods are calibrated using an official method of analysis, right? Using a reference method. That's all these terms, you will hear about them and they mean the same thing. If you hear it's an official or a reference or a primary, it's called primary because it's a method that is the first one you do. And if you want to calibrate something else, it would base on it. So it's another name, but they all mean the same thing. So if you want to generate a nutrition label, you have to use official methods of analysis or primary or definitive or reference. They all mean the same thing. So you cannot just use any method that does not have the stamp of official method of analysis. However, you want quickly determine some quality characteristics. Well, I just need to make sure that my grain after before I mill it into flour, for example, doesn't exceed 12% moisture. So this quickly, I just want to make sure that my grain, my whatever wheat or what have you, is 10 to 12% moisture before I do anything. So I can quickly do it using NIR or using moisture balance or what have you. We'll talk about a lot of different methods that are called secondary methods of analysis. They have been calibrated using primary methods of analysis. Okay, rapid, quick, not official, and needs to be calibrated. All right, online processing management, measurement. Sometimes you are processing, you're producing, let's say, yogurt online or concentrating milk. You're producing a milk concentrate or what have you. So you measure, let's say, either acidity online or moisture content or the pH or total solids. So this is something you do during the process. It going from one unit operation to the other. So again, it has to be a quick method. So it has to be calibrated as well with official methods of analysis. So if any of you worked in the pilot plant, they have an IR instrument that they use to quickly measure certain components. They also have the microwave for moisture analysis, quickly for their cheeses, for example, that they produce. So, yeah. And there are also any secondary method, it's called secondary because it needs to be calibrated by a primary. All right. So the choice of method is also based on the type of food or ingredient we are testing. So if it is so the composition mainly, we look at the macromolecule compositions. So moisture content, fat content, protein content, carbohydrate content. Depending on the composition of the sample, you might need one method over another. And I'll give you an example in a little bit that kind of explain this here. So when we cover the fat analysis chapter, we're going to learn about two major methods. And there will be sample prep associated with each of these methods based on the composition of the sample. So each group later on will have one food product that they will work on it over multiple labs to determine its composition. So let's say you have a cheese product versus a cereal product, different composition. What strikes you first, the difference between the cheese product and the cereal product? What's the big difference between in composition, in micromole?
Cheese is mostly fat, cereal is mostly carbohydrates.
Very good. Cheese is mostly fat and proteins. And then cereal is very high in starch or fiber, carbohydrates. So, and very low in fat. Also cheese can be high in moisture, whereas cereal usually low in moisture. So very different composition. So let's take this example. You are determining fat content in a food product that is high in moisture, carbohydrate, and or protein. They don't necessarily high in all three of them. But you're looking at analyzing fat content. So the sample preparation may include, what do you think? Get your best guess out, and then I will tell you. You're after fat content. If the sample is high in moisture, you may or may not need pre-drying. Why would you need acid hydrolysis, for example? Think from a chemistry perspective. Okay, take a guess and I'll explain. What did I say last time? When you're not sure, you go with? Okay, Scarlett. So all of the above. We will learn two different methods in food analysis. One, you really have to dry your sample if it is more than 10%. And that is Soxhlet, and we'll learn about it. Because there will be interference, the solvent, the organic solvent reaching the food to get the fat out. High moisture content will interfere in the process. But another method called the Mojonnier or Mojiner method, we don't need to pre-dry. So it depends on the method. But if you have high carbohydrate or high protein, the fat could get entangled or interaction. There might be interaction between protein and fat or carbohydrate and fat. So when you're extracting the fat content with a solvent to determine how much fat you have in the sample, this other components can cause interference and prevent the solvent from solubilizing the fat. So if you do acid hydrolysis, it will break the proteins, it will break the carbohydrate, it will be easier to extract the fat. So this is an example that illustrates if you do acid hydrolysis and if you don't do acid hydrolysis. So there's dried egg, yeast, flour, noodles, semolina. And then if you're trying to get the percent fat without acid hydrolysis, dried egg is high in protein. Not sure what the yeast is really high in, but flour, noodles, and semolina, they're really high in carbohydrates, a lot of fibers and stuff. So if we don't do acid hydrolysis, you underestimate the fat content. All of these values are lower than if you do acid hydrolysis. Because now the acid broke off the carbohydrate, the proteins from the dried eggs, so you were able to extract with the solvent more of the fat. Same for the other components, breaking with carbohydrates, so that the fat can be released in the solvent and you can quantify it. So quite a bit of a difference. Even though the flour has low fat, you can see it's almost like 25% more extracted using acid hydrolysis. So the composition is very important in selecting the method of analysis. So every time I introduce methods of analysis for any component or any characterization, I will talk about the impact of the food matrix on your choice. So this is just introduction to that. All right. Then when you choose the method, you also want to choose a method that have certain characteristics. Okay, so we talked about specificity last time. How specific do you want it? Are you looking for total carbohydrate, or are you looking for a particular components of that carbohydrate? Lactose, glucose, sucrose, what are we looking at? Starch. So specificity. So we choose based on the specificity of the method. We also talked about precision and accuracy, how precise, how accurate. Can it be reproducible? Every time I run the assay, is it going to give me the same range of the data? And sometimes to check a validity of a method, let's say you work in an analytical lab in a company and you found that one method is quicker for you, you with less resources, and is less expensive, and you have training. You have to convince your company that you're going to go with this method. So you have to prove its validity. There are different ways to prove it, and sometimes you get a standard reference material from the National Institute of Standards and Technology, NIST. They give you a standard material. They give you, let's say, if you're looking for total protein, simple. You get a standard material analyzed by a specific method, and then you're testing your sample. If your value lies within what the standard material value should be, then you go, okay, I'm good. Another way of testing your method is you can have check sample services. So the same method you analyze with your method, you can send it off to American Association of Soil Chemists lab or AOCS lab, American Oil Chemist Society, or what have you. And then they analyze the sample and they give you the results, and you compare to the results that you've gotten. Sometimes you also have an internal control sample. So you would measure it with two methods, and if you get similar results, then you validate your method. Okay. So from here on, few slides, FYI. So the official methods of analysis can come from different organizations. The AOAC is called Association of Official. It used to be analytical chemists. It became agricultural chemists. They just changed that word, but the abbreviation remained the same. And then AACCI, which is now under the organization that is called Cereals and Grains. But the methods of analysis are put together under American Association of Cereal Chemists International. So these are mostly for cereal products. AOCS is American Oil Chemist Society, mostly for fats and oils, but they have a lot of protein-related tests in there as well. And then there are others, like the American Public Health Association. They have standard methods for dairy. And then there are also standard methods for wastewater. And then we have the US Pharmacopoeia, which is Food Chemicals Codex. So there are a lot of different organizations and a lot of different standardized methods of analysis. And in your book, there are tables that show, for example, here the AOAC, the different chapters and what type of methods you can find there. So if we had a project in this class, a project that I canceled, a lot of times you have to go to these references and find those official methods of analysis. You have access to them if ever in your capstone or research, undergraduate research project, or later on if you go into the industry, these will be a resource that you go to, these official methods of analysis. And then as a student, they're available to you through the library as well. This is the American Association of Cereal Chemists approved method, also the different chapters and what are the different tests. And then for the Oil Chemist Society, these are all FYI at this point, but for you to know where to find a specific method if you're ever looking for an official method of analysis. This is specific for dairy, and that's it. All right. Any questions about anything so far? Related or not related to what I was talking about? Okay. Let's go to nutrition labeling, which will be the subject of your lab on Wednesday. Do you all know where to go on Wednesday for the lab? It's in my email. We're going to go to Hacker Hall, the building adjacent to our building, and 4th floor and 445. Yeah. This is the only time we're going to go to that lab. It's just because it's a computer-based lab. And then later on, it will be ABLMS 135. Yeah. But not this Wednesday. All right. Let's see. Read that for a minute. Make a guess. FDA stands for Food and Drug Administration. FSIS stands for Food Safety and Inspection Service. Any brave soul? You're all brave souls, but anyone want to answer? Go ahead, Anne.
Is it C?
C. It's a very good guess. Hold your thought. Okay. Anybody else? Marie. It is correct in a particular era. Ali? No. Yeah. Ali, yes. E. It's 50% correct. So when in doubt, Madeline. I wish. Manufacturer would love that to be correct. Oh, wait, oh, you just walked in on me. Wait a second. I didn't see you come in. Katie?
Okay.
Yeah.
Another.
Aha. So when in doubt and there's no all of the above, could be none of the above. Like to confuse you a little bit. But, all of your answers are partially correct. So percent daily value for protein is mandatory if you're making a protein claim, or if the food is specific for a certain category of people. We're going to have a chapter on protein and when to label the percent daily value. Maddie, you said D. Manufacturers would love that, but because it's nutrition labeling, it's regulated by government, you have to use official methods of analysis. So the manufacturers run the assay, but they have to use official methods of analysis. Let's see what other B, that was correct in 1973 to 1990. The nutrition label at that time, it was not mandatory, and it was only if you're making a nutrient related claim or health related claim, then yes, you would have a nutrition label. But in 1990, the Nutrition Labeling Act told you that no, we have to have a nutrition label for most food, yet not all food, but we'll get to that. Were there any other answers? Oh, E. It is correct for vitamin A, but not anymore, actually. I believe in 2021, there was a new format of a nutrition label that was approved that doesn't have any more vitamin A as a requirement. Now it's only vitamin D. We used to have vitamin A and vitamin C as a requirement, but they were removed and it's now only vitamin D. We'll get into that. Vitamin B12, it was never a requirement for that. Okay, so I just wanted to see which answer you would pick, and so that I have a reason to talk about each one of those. Okay. So food labeling regulations are mostly regulated by the FDA of USDA. So FDA is part of USDA. But specifically meat, poultry, and egg are regulated by FSIS of the USDA as well. Okay, so that's that. Now, if we want to think about over 100 years ago, what they did, the label on the food only, you were required, of course, to put the amount on the package, to put what the actual name of the food is. It cheese or not just the brand name? So you have to put the common name and then the list of ingredients. That was based on these older acts. But then there was an FDA Regulation Act in 1973, a little bit of a history, that required nutrition labeling for certain instances. First, are you making nutrition claim, nutrient or health claim, or did you add fortify? So like you added calcium to orange juice, you have to put a nutrition label in that case. So it was and it was optional for other foods. So you can or you don't have to. But then in 1990, the Nutrition Labeling and Education Act made it required for almost all foods with few exceptions. And then we started putting a lot of the nutrient components and nutritional value and percent daily value, and we'll talk about that. So this is what I said in terms of earlier on, if you added a nutrient that wasn't there, or if you're making a claim, then you will have to put a nutrition label. And at the time, the consumer was more focused on macronutrients and calories. So they were not really focused on micronutrients. And then later on, there was, interest in sodium intake, that's a micronutrient, vitamin intake. So that expanded into a new law that requires us to put nutrition labeling on most of foods. So there are foods that are exempt. Do you know of any food products that you would go buy and not have nutrition label on, Emma? Alcohol. I wasn't thinking about alcohol. She always, you always like to stop me, don't you? And don't we have a label on beer? I thought we did, for example, like sugars and calories, because we have a lab on that. And we compare our total carbohydrate and calories to what is put on the label of the beer. Can you look it up quick and let me know? I thought we did for calorie purposes and for like for this. Yeah, I thought. At least for beer.
Wine and stuff.
Wine, no?
Liquid.
Okay. Yes.
Very small packages.
Yes. Yeah, small packages or like packed within a bigger container. So on the bigger container, you have nutrition label, by little packages you don't. Yes. Another one, eggs. Have you seen nutrition label? Some people put, I don't know why, some companies do, but you're not required. Or game meat. Yeah, so there are certain foods that are exempt. But most foods you would see a nutrition label. Did you look it up? Do we have nutrition label on alcohol?
Not necessarily for beer, it's not a federally required.
It's not federally required. So the beer we analyze in the lab, it just seems to have it on the label. Huh? Yeah, but like if you're claiming like we're gonna analyze Budweiser and Budweiser Light. In order for it to be light, it should be content. Okay, so
Oh, I see it.
okay, all right. Well, there you go. Thank you for that again. All right. There has been changes over the years of the nutrition label. It's specific in 2003, they added trans fat. It wasn't part of the 1990 act that you add trans fat to the label, but because of complications with trans fat and its relationship to cardiovascular diseases, and because of hydrogenation and impartial partial hydrogenation can lead to trans fat. So if we take oil and we want to produce margarine or partially hydrogenated fat, you might convert some of the cis fatty acid to trans fatty acid, and this is not good to us from a health perspective. So it became requirement since 2003 to put trans fat on the label. All right, but then this has changed. It took a long while for this to get approved and enacted. So there is the date of when it was proposed, when it was approved, and then there was a long period, about 6 years before it was enforced. And this is currently the new required nutrition label. What do you see differences that's right? Yes, Kate. The added sugar is a big one. Yes, so people can know how much of the total carbohydrate is coming from sugar out. Oh, calories? No calories from fat. That is very good. And speaking of calories, what do you see here that is like really jumping at you, Mary?
The calories are
Bold, screaming at you. Big and bold, the calories. Yes, very good. What else do you see? Go ahead, Mary.
The serving size is also bolded.
Yes, the serving size is also bolded. So the calories bolded per serving, and then serving size so that people will see that first. But If we look at components, what do you see other than added sugar that was different? Go ahead, Alexander. So yes, so under two things in the vitamins and minerals section. So vitamin D was added. So it used to be vitamin A and C, but deficiencies in vitamin D over the years became an issue. So and no longer vitamin A no longer is an issue, or vitamin C. There are a lot of fortification in different products. So it's not an issue as much. It might come back as an issue if people don't eat enough. What is the disease associated with vitamin C? That's a college bowl question. Scurvy. Yeah. Anyway, so now it became that since we have vitamin D deficiency, whether we're not sitting in the sun or not taking supplements, so it became a thing. So they put it. Potassium is a mineral. It's not a vitamin, so it's a mineral, but also associated with cardiovascular health. So they added it. It wasn't there. It was only calcium, iron, vitamin A, vitamin C in that region. So now it changed. Vitamin D was added, vitamin A and C left, and then potassium was added. Anything else? No. Sodium is there, cholesterol is there, dietary fiber, total sugars, protein is there. So these are the major changes. Okay. So when we do the lab on Wednesday, you will see that some of these components require percent daily value to be included. Protein only if we're making claim related to the protein, or it's a product for small children. So you will see percent daily value, and how it's calculated is per serving. So basically, if you have 15 grams of fat in your serving, what is the percent of the daily value? Or in this case, it's called daily reference value. It would be 15 by 78 times 100. So in that serving, you're getting that particular percent of the total per day that you should be eating. Okay. So that's what it is. And then the reference daily intake is specific for vitamins and minerals. Also, these are specific. And again, daily value, percent daily value that you see on your label is coming from these. Sometimes age group, depending on the age group and whether it's a female or male, you might have different requirement of certain vitamins and minerals. But this is usually for an adult, and they usually go with an adult female. So for example, iron, 18 milligram is usually for an adult female. I think for adult male, it's about 9 milligram, but they shoot for the highest possible. And that's what would be the target for your percent daily value. Okay, so this is also FYI, important FYI, if you ever work in an industry that you are responsible for rounding and producing your nutrition label, you want to understand that. So this would be a good reference table, table 3.3. So for example, if you have calories less than 5 calories, you can report as 0. Okay, so if you have 2 or 3, you don't have to report that. And then for different components like total fat, if it's less than 0.5 grams per serving, then you can express as 0. And then there are rounding rules as well. So you express to the nearest 5 milligrams for cholesterol, for example. So these are important to know when you're actually working in that domain. Now, I wouldn't test you on that. be very mean of me if I test you on that. Okay. Caloric content, there are different ways to calculate or determine the caloric content in a food. There is the calorie bomb. Have you heard of that equipment? You put the food in a equipment and then boom, you burn everything off and you just record the energy. But oftentimes you just add calories based on the composition of the food. So 1 gram of protein is equivalent to how many calories, you know?
4.
4. Very good, Maddie. So 4. What about carbohydrate? 4. Very good. What about fat? You remember that one?
9.
9. Very good. So yes, and it is in kilocalories. So, and then you would see it as calorie with a capital C. So 1 gram of protein, 4 calories, 1 gram of carbohydrate, 4, 1 gram of fat, 9, and then you add it up. And often, if you have high percent of dietary fiber, you don't want to include the dietary fiber because they're not digested and they don't amount to calories, really. So you add up those main components of food and calculate the calories. Now, if you have alcohol, 1 gram of alcohol is... You would wish. Anybody? Maybe 7. Yes. You have a nutrition undergrad? Okay. Yeah, so 1 gram of alcohol is equivalent to 7 calories. So unfortunately, when you drink alcohol, you're drinking calories. Okay. So protein quality, we will have a lecture expanding on protein characteristics, but in order to calculate percent daily value, you don't usually, if the requirement is, if the requirement on average is 50 grams per day, but it's really depending on your weight. So it's 1 gram per kilogram, but they say, well, okay, 50 grams per day is the requirement. And then your serving has 10 grams protein. Do you usually go 10 over 50 times 100? So I am getting, what am I getting? What is that? 10 up, right? What is it? 20%. Yeah? Right? I'm doing the math right here. Gosh, my brain is going. Yeah. So, do you do that? No, we don't do that. Why, Katie? We don't do that. Do you know why? Anybody? Huh? Well, it's different for everyone, yes, but it's not just quite that. You know why we don't do that? Do all proteins from different sources we digest the same way? Some protein are not as digestible as other protein. So if the protein does not get fully digested, we don't get all the amino acids. It don't get absorbed all. So there is something we call the PDCAS, protein digestibility corrected amino acid score, or protein efficiency ratio for infants' food. So some proteins have a value of 1 for PDCAS. That means it's a complete protein. So you have all the amino acids and it's 100% digestible. So yes, if you have 10 grams in the serving, yes, you're getting 20% of your daily value. But some proteins like pea protein, for example, if it's the main component in your food, it has about, on average, 0.8 PDCAS. So you have to go, okay, no, now it's not 10 grams. It's really available is 8 grams. Because you multiply that 10 gram by the availability value or PDCAS value. Then you have less than the actual amount of protein in the serving. So you take into account that. So that's a little bit tricky for protein and different components. All right. Did I say that already? Probably did. Remember what the answer would be here? Correct, maybe. So it's definitely B and also for D for kids that are less than 4-year-old because it's important for their growth. So it's B and D. Okay. Compliance is a big deal. So sometimes the company gets audited. So they come in and they take samples and they evaluate the components in comparison to the nutrition labeling. If they're not in compliance, they are in trouble, and the trouble can vary between fine or shut down or whatever. I don't know what they do, but they have to be in compliance. So compliance meaning you follow the rules of sample collection. We'll talk about sampling later on. There's a specific number of sample that you have to pull out if you want to do analysis for nutrition labeling. And then the methods need to be official methods of analysis. Now, the last one, which is very important, and these values I want you to know because I can ask you about those. They're not hard to remember. The level of compliance. So if you have an added nutrient, let's say you fortified with vitamin D, whatever you claim on that label should be equal or greater than 100% because you added. So your level of compliance is minimum 100%. If it's naturally occurring, and it happens a lot that the protein content, for example, does not match what the label says, but if it is 80% at least, that you're fine. So if you're claiming 10 grams of proteins in your serving and it turned out to be 8, that's okay. It's still 80% of what you're claiming. So at least 80% or more. Now the negative components, fat content, total sugars, calories, you cannot have more than 120% of what you're claiming. If you're claiming 100 kilocalories and then the analysis showed 150, that you're not in compliance. But if your analysis showed 118 and you're claiming 100, it's fine. You're within the 120% limit. All right, so guess what? Last time I stopped here. So this means I'm going the right pace, but this is just to tell you what you're doing on Wednesday. You need the lab manual version 4. And then we're going to use the Tech Wizard program version 6, and it's installed on the computers in that room that you're going to and has been tested by our TAs. So you're going to prepare nutrition label for a yogurt formula, and then you're going to change the composition of that formula and see how the nutrition label will change, all on the computer. That you're going to change the formulation and see how that impacted the nutrition label. And then you're going to add ingredient. So you will learn how to add an ingredient that wasn't in the original formula and that is related to calcium, and then increase the daily value to 50% of calcium, and then increase it to 100% of calcium, and see how the formula changes. You're going to observe a reverse engineering to go from having a nutrition label and a list of ingredients to get the formulation rather than having the formulation and then get the nutrition label. And then you're gonna be given a chocolate chip cookie composition, the ingredients, and you're going to produce a nutrition label. So it's pretty straightforward if you follow the instructions, and we will guide you through it during the lab. Chapter 3 in the textbook would be helpful, and chapter 5 is what you will be following in the lab manual. There is a lab intro video, it's already up. Gray put that up. And also he put your pre-lab quiz up. The assignment is due by 9 a.m. I say here Monday or Wednesday because we used to have a Monday lab, but it's Wednesday for you. Bring a lab notebook, and you may ask, what kind? Any kind. It would be good if it is the size of an A4 because sometimes you print your results and it would be nice to just staple them directly in your notebook. Yeah, and there are specific handouts related to the lab on Canvas in the first part of the module section. All right, and this is where we're going to meet in Hacker Hall. I'll give you a little bit of an general introduction to the lab and requirement, and then Gray is your lead TA. He will walk you through the program, and then we will go through that. It's a very interesting experience. It's the only non-real like wet chemistry lab, but you will need it potentially in capstone. You will need it later on in life, maybe different program where you go in industry, but at least gives you familiarity. Please come on time. I think lab starts at 9:35 officially on your transcript. If you're there at 9:30, that would be really helpful. See you on Monday morning. All right, thanks.